All right, tonight what we're going to be talking about is how to draw basic covalent compounds. And if you remember from before, covalent compounds are when you share electrons. So what we're going to do is we're going to show compounds that actually have to share the electrons in order to get their octet, as opposed to giving and taking of them like ionic compounds do. Now, what you're going to need to do for every single problem is follow a certain set of steps. So the first thing that you're going to need to do is count the number of electrons. And when we're talking about electrons, we're talking about the valence electrons, or the electrons that are involved in bonding. Well, which makes sense when you're trying to draw covalent compounds. We're only talking about how they're bonded, so that's why we only care about the valence electrons. So when you're counting them, all you need to do is count how many each individual has and add them all up. Okay, then what you're going to need to do is draw them. And if you follow these steps, it is a general blanket statement that these work, but it's not the end-all be-all. So first you're going to have to draw the arrangement of the atoms. And what that means is how are they going to be placed in the bond. There are a few hints when drawing it. First, the first element is typically written in the center. That is not in always, but that is a typical. If you have a carbon in this class, it is almost always in the center. That's why it's actually written first typically, because it is the least electronegative considering the other elements, but it also is staying in the center typically of a drawing. The only exception is that hydrogen sometimes is written first, but it is always on the outside. And the reason why is because it can only bond once, and the reason why it can only bond once is because it has one valence electron, so it will only be able to bond at that particular place. Halogens, which are, if you remember, the chlorine-fluorine column, or the one with 7 valence electrons, can also only bond once, and so they are almost always on the outside. There are very, very few exceptions where they are not on the outside, and in this class, you are to assume that they will always be on the outside, so they will never be in the center, even if they are written first, which they shouldn't be. Then what you want to do is try to draw it as symmetric as possible. So by symmetry in this case, I'm talking about if I had a mirror, would it look the same on the left as on the right, as on the top as on the bottom. The next step is once you have them all placed, then you want to draw the Lewis dot structure for all the individual elements, which we've already done in previous units. And then you're going to try to form a bond with any lone electron. And we'll talk about this more and more when we actually start drawing the structures, but you're going to form a bond with any lone electrons. Lone pairs you're going to leave alone. And for this class, you should never try to make a circular structure. So something where, like, let's say one atom is attached to another atom, which is attached to another atom, which is then attached to the first atom. This is going to be a no-go. All right, and then you're going to try to redraw the structure so that it's a little bit neater than what you originally started with. So we're going to start some examples, and the first one is we need to figure out the number of electrons for Br2. If you know Br has 7 valence electrons, so to count all of their number of electrons, each Br is going to contribute 7, but we have 2 of them, so that's going to be a total of 14 electrons. So there's going to be 14 valence electrons that I'm going to be dealing with. So now I'm going to need to practice my drawing of my structure. So the first step is draw the arrangement of the atoms, and it says put the most electronegative in the center. Well, in this case, there is no true center, so you're going to draw both of them just right next to each other. Okay. Then it says to draw the Lewis dot structures for all of the individual elements. Br has 7 valence electrons. I'm going to draw 1, 2, 3, 4, 5, 6, 7. Okay, and now instead of drawing a lone pair like this with 2 lone dots, what we're going to do is anytime that you have a lone pair, we're going to draw a line. And this is no longer called a Lewis dot structure, it's called a structural drawing, but we always reference it as Lewis dots. So in this class, they're going to be the same thing, even though technically they are not dots. So this other Br that I haven't dealt with will also have those. Okay, notice that I'm arranging it a little bit differently. I think I'm going to go with yellow for this so that you can see it a little bit better. But this is my second step. So draw the Lewis dot structure for all the elements involved in a compound. Now I need to form a bond for any lone electrons, because if I notice this Br only has 7 valence electrons, this Br only has 7 valence electrons. So what I want to do is make sure that all of them have 8. And how do they do that? Well, in covalent compounds, what they're going to do is they're going to share them. So I'm going to show that this is a bond. What's happening with those electrons right here is that they are sharing them between both BRs. So at some point the electrons will be found on the first BR and on the second one, and at other times they'll be on the second BR. So when I redraw this, okay, where it says redraw the structure, what I'm going to do, my steps for redrawing it, is redraw all the elements. So BR. That's step number 1. Step number 2 is draw any lines or bonds. For every individual circle that I have connected between each lone or unpaired electron, that represents one line. So in this example, I only have one of those circles, so I'm going to draw one line. That line right there represents a bond, and that would be considered a single bond because I only have one line going between them. Then what you want to do after you've drawn all the bonds is you redraw all of the lone pairs. So in this case, the BR on the right had 3 lone pairs, and the BR on the left had also 3 lone pairs. Now I'm going to check. So how do you check? You first make sure that everybody has 8 electrons. So in this case, BR has 2, 4, 6, 8, okay? Because whenever you have a bond, pretend each line represents the 2 electrons that are on that BR at that time. So that way I was happy. And this BR has 2, 4, 6, 8. So everybody has a full octet or 8 electrons. And then the next step that you want to do just to check is you're going to make sure that everybody has, that should be one line. Everybody, you've only used those 14 total electrons. So I'm going to count total number of electrons. So it would either be 14 individual electrons or 7 lines. So I'll count the lines. 1, 2, 3, 4, 5, 6, 7. So because I only used the 14 valence electrons that I had, and everybody has 8, I know that my structure is correct. Now we're going to try a different structure, CO2. And with CO2, we're going to follow the exact same steps. So you're going to draw the arrangement of the atoms. Remember that the first element typically is going to be in the center, and in this case it's carbon, so it almost always is. So you're going to put carbon in the center. Then what I'm going to do is I'm going to try to make it as symmetric as possible. So I'm going to draw 1 oxygen on the right and 1 oxygen on the left. Okay, so now it looks as symmetric as possible. I'm ready to move on to step 2, which is draw the Lewis dot structure for all the elements involved in the compound. So carbon has 4 valence electrons. Oops, I forgot to do all the valence electrons for carbon dioxide. So let's go. Carbon has 4 valence electrons, and I only have 1 of them. Oxygen has 6 valence electrons, and I have 2 oxygens. So this would be 4 plus 12. So we get a total of 16 electrons that we can deal with. Okay, so that was step 1. I forgot to do that. Now we're going to move on to step 2 of steps for drawing the Lewis dot structure, which has 4 valence electrons. So we're going to draw 1, 2, 3, 4. Each oxygen has 6, so that's 1, 2, 3, 4, 5, 6. From now on, remember, anytime we have them partnered up, we're going to draw a lone pair, making it a line. So I've already drawn 1 oxygen. I can draw the other one. On this side, I'm going to make it black or dark blue. 1, 2, 3, 4, 5, 6. So that's going to become a line, and that is going to become a line. All right, now I'm ready to start partnering up my lone electrons. So the first one that I notice is between this guy and that guy. So that would be that would make 1 bond. This carbon has a lone electron here, and it has 1 on that oxygen, so I'm going to make a bond there. All right, now I see another bond here between a lone electron and another lone electron on the oxygen. And my final one, I'm going to see, oh, look at this. Now, this does not look neat at all, but that's the whole reason of why you draw the final structure. So that it makes it look a lot neater. So what I'm going to do is I'm going to draw my elements again. So I've got this carbon, got the oxygen, and I've got another oxygen. Right, now I'm going to draw the bonds in between. So step 1 is once again draw the structure. Step 2 is draw the bonds in between them. So I'm going to look at this guy, and I'm going to reference it as the purple line. So that represents 1 bond in between that C and that O. Then I see another one right there between the orange C and the yellow O. So I'm going to draw another bond there. These should all be the same colors. I'm just trying to visually show you how the bonds actually are formed. Okay, then between the carbon and the blue O, I see a blue line, which would represent a bond. So that would be 1 line. And then between that carbon and that blue oxygen, I see another one right here. So I'm going to draw another line. Really important that you draw the bonds between the elements and not on top of them. On top does not show that they are sharing it. It shows, I don't know what it actually shows, but what you need to do is make sure that they're actually drawn between your structures, because otherwise it becomes very confusing and it doesn't look like a bond. It kind of looks like a lone pair that has extended itself. All right, so I've drawn all the bonds. Now I'm ready to draw all the lone pairs. So I'm going to work from left to right, and I notice that my oxygen on the left has 1, 2 lone pairs, so I'm going to draw 1, 2. The very important thing about where to draw lone pairs is it really doesn't matter where you draw them. The only place you cannot draw them is actually in between a bond. If you ever draw it in between a bond, you have put way too many electrons on that one side, so therefore it will be considered wrong. So it doesn't matter if you drew your lone pairs on that side and the top and the side, or if you do the top and the bottom. It really doesn't matter as long as it has 2 lone pairs and it's not in between the element and a bond. If I look at my carbon, I see 0 lone pairs, so I'm going to move on. And then if I look at this oxygen over on the right, I notice that there's 1, 2 lone pairs, so I'm going to draw my 2 lone pairs. So notice on the blue oxygen, I have 2 lone pairs written on top and bottom, and on the yellow oxygen, I have them on the top and side, and both are perfectly correct. These are actually called double bonds. Think of baseball. Single bonds would be a single line. Double bonds would be 2 lines in between 2 elements, and 3 lines would be a triple, just like baseball. All right, so when we're talking about types of bonds, what you need to do is you are going to need to know that single bonds would represent 1 line, double bonds would be 2 lines, and triple bonds would be 3 lines. Once again, just like in baseball. You hit to first, second, or third base, single, double, triple. The number of electrons, once again, each line represents 2 electrons. So a single would have 1 line, so that's why it's 2 electrons. Double has 2 lines, so that's 4. And a triple has 3 lines, so that's why it would be 6. As far as strength goes, it makes sense that a single would be the weakest and a triple would be the strongest, because you have more things that are being shared in between. You kind of get more and more involved. Those elements become more and more attached to one another. But what's surprising is that because they get more and more attached, actually as you go down or as you increase the amount of bonds, your length actually decreases. So notice that the triple bond is actually the shortest, whereas a single bond is actually the longest. So think your distance is shorter and you are stronger and more connected. All right, hopefully you understand how to draw a basic covalent compound. Make sure you follow these 4 steps that we've talked about. Oh, and I guess what we should do is check our work. So I'm going to go back to here. I apologize once again for checking our work, because it's very important that you check your work. And so very important first thing that you need to do is check how many valence electrons everybody has. So oxygen in the yellow has 2, 4, 6, 8. Carbon has, if I erase those, carbon has 2, 4, 6, 8, so it is happy, and this oxygen has 2, 4, 6, 8. So everybody's happy as far as the amount of electrons everybody has. Now you just need to make sure you only use the right amount of electrons. So I can use a total of 16 electrons, so counting, that would be 8 lines, because each line represents 2 electrons. So it would be 1, 2, 3, 4, 5, 6, 7, 8. So I am perfectly content with my drawing. Everybody's happy, and I've only used the total amount of electrons I should. All right, so now we are actually done with this. I hope you guys have a good night and have a basic understanding of how to draw Lewis dot structures for covalent compounds.